Hi there, thanks for stopping by. My name is Dana Royer. I'm at Wesleyan University in Connecticut. I'm one of the PIs on the CO2 PIP team. And let me first say thank you so much for your willingness to put time and effort into this community project. We're going to sink or swim based on your efforts writ large. And so thank you very much. I suspect you clicked on this video because you want some tips on how to fill in the templates for estimates based on the Franks model. So I wanted to whirl through that and hopefully help you out with that. What you're looking at here is what we call the blank template, which has the column headers here, and actually one column above in row 2 is a more fuller description of the column header. So if the column header leaves you a little bit confused and you want a little more information, you can click one cell above and hopefully that will help. Those cells mostly come directly from information that's in the R code that probably a lot of you are familiar with, that's associated with estimating CO2 from the Franks, using the Franks model. And then rows 5 through 7 are example data that basically give you a sense of our expectations, the kinds of information that you might see in each of those cells. So it sort of gives you a guidepost for when you go to fill in your data, so you're not starting in a vacuum. What I encourage you to do is fill in your data starting on row 8, and then when you're finished and you're ready to submit, make sure you delete rows 5 through 7. If you have leaf level data, we strongly encourage you to enter in those leaf level data where each leaf gets its own row. This is going to help us, we think, in the future in managing the data. Now, when you're estimating CO2, that's generally based on species averages. And so if that's what you did, you would enter your leaf level data, and then below, for a single species, you would have an additional row where you report the aggregate, the means of stomatal density, and all the inputs, and as well as your estimated CO2. And then when we get to the product file, we can express it in a way that we know to ignore the leaf level data and only focus on the species means. If you have multiple species from a single site, you're going to want each species to have its own row or series of rows if you're doing leaf level data, but everything in one spreadsheet. So the spreadsheet should represent all the data for that one method from that one paper. So if there are multiple species, you want to have them all lined up down as you go down through your rows. As you look at this spreadsheet, columns A through J are common to all of the templates, all of the proxies. And we do that so that it's easy to machine read in the data across all the templates. So for some of these columns like age and CO2, that's information that's repeated in columns further to the right. So it may seem a bit weird at first, but the reason is we want all the common columns there at the beginning. Here it's columns A through J. Now we've made this a bit easier for you because these are all set up as equations. And I think we've locked these columns. So in fact, you can't even manipulate these cells even if you wanted to. But you can just leave them alone. They'll fill in automatically as you fill in the appropriate columns to the right for CO2 and age and the DOI. But you do need to type in your cells for columns A through C. Column A will be identical for every Franks model estimate. So you can just drag that down. Yeah, and then moving forward, if we scoot over a little to the right here, these green columns give general information about the paper, the study, about the site where these fossils came from, and about the fossils. So sample name, which sounds a bit vague, that's meant to be an all-purpose cell for Any additional information you might have about identifying these specimens or suite of specimens if it's a a species mean. So you can see here, these rows are species means, and so what we're calling the sample name is the locality, and this numeric, this number, this string here, 9916, is the museum ID for that particular site. So that's going to be helpful. So any information that you think could be helpful along those lines, you can put into column O. Taxonomic information. If there's something that you don't know, so this is a species that's unknown, the genus is known, but not the species, type in NA. There shouldn't be any blank cells in any of your entries. If you don't know the information for whatever reason, either because it's not appropriate or it's just not reported in the paper that you're entering, please type in capital N, capital A, exactly as that. And that's going to help us. Column S is, where are these fossils? What's the repository? If for those fossils that we want to go back to and modernize them, this is actually a very important column. This is very helpful information. We need to know where to go to find these fossils. Stratigraphic level, this potentially opens a bit of a big box here, but what's the stratigraphic context for this locality? A lot of times it's going to be a meter level relative to some benchmark, and that is in fact the case for these sample data, which are referenced against the KPG boundary. So this is a species that, a set of fossils that were found at a site 4 meters above the KPG boundary. It could be more generally a biostratigraphic age, like Maastrichtian, or even a regional age, like a North American land mammal age. Anything that's going to help us, because the ages, we want to be able to continue to update the ages as the geologics community's sense of timescale, gets refined. When the new geologic timescale books come out, we want to be able to go back and, in a fairly efficient manner, update any ages that need to be updated. So this column U is actually quite helpful in that regard, particularly if your ages are based on biostratigraphy or just more generally about stratigraphy. We have these age columns. You want to enter in the ages as they were reported in the paper. We think of these archive files, these templates, which we're calling them the archive files, as pristine. We don't ever want to tinker with them again. Once they're submitted, we want to seal them off and they're preserved. And they should never change if we've done a good job. Any updates, so if we know that the ages have changed, if we want to update how the CO2 estimates were calculated, that all goes into a companion file that we call the product file, which at least at this point, I don't think many of you have seen. Those will have different versions moving forward, but the archive is going to stay pristine. For the uncertainties on the age, make sure you type in the absolute value, not a plus or minus. So you can see that's what we've done here in millions of years. Yeah, if there was a timescale book associated with the ages, you can type that in here. So actually this probably should say GTS 2020 because it is assuming a specific age for the KPG boundary of 66.0 million years ago. And then a more general description of how was that age determined. So it could be as simple as biostratigraphy. If you typed in column U that it was Maastrichtian, well, it's based on biostratigraphy. You could go into more details about what kind of biology was used for that biostratigraphic age. The more information, the better, but it's up to you in terms of what you want to put in there. If it's based on geochronology or magnetostratigraphy or any combination of things, you can see here, that's what we've done for this set of fossils. Any information you can give us, that would be great. Hopefully, you know the present day location of the locality. You probably won't know the paleo, or we don't really expect you to go and search that out. What we will probably be doing is using a single method for converting present day lat long to paleo lat long. So probably you're going to be typing in NAs here. All right, column AE, this is sort of the money column. What is CO2? That's an important one. Again, stick with what was published. Now with the Frank's model, the way that we're using the Frank's model these days, it's based on a series of Monte Carlo simulations, and typically your estimated CO2 is the median of those resamples. So that's why these all say median. But you could take the average, right? If you have strong reasons to do that, or some other, whatever you did, you want to type that in. Probably it's going to be median. You want to put the uncertainties of your CO2 estimate. Again, based on what was published, type in the absolute values for the low and the high. Don't do plus minus. And if you forget, that's what it says right here. Give as an absolute value, not plus minus. With those two columns, AG and AH, what do those represent? Now with CO2 PIP, we're striving for a uniform, standardized way to present our uncertainties. We would like them to be at the 95% confidence. This is something that we can do or adjust with the product file, but that's what we aspire to. And thankfully, with this original publication, that's what was presented. So with the Monte Carlo simulations, 95% confidence, what you'd be reporting in columns AG and AH would be the 2.5 and 97.5 percentiles. So that's what's typed in here. What does the probability distribution of that CO2 estimate look like? Is it bell-shaped, like a Gaussian distribution? Is it skewed towards high values, which in fact, all of the Frank's model estimates that I've produced, that's what it looks like. There's a tail at the high end of CO2. So all of these say right skewed for that reason. How were these fossils measured? We really are hoping that that's based on actual microscope work and not based on published images or plates. So you can see here, microscope. Assuming it was done with a microscope, what's the field of view? You could type in the magnification, you could type in what the actual geometry in microns was, or if the area is given in microns squared, you could give that, or millimeter squared, whatever is given in the publication, that's what you want to type in and make sure it's clear in this column. Okay, now I can move a little bit faster here. These purple columns, if you're familiar with how the Frank's model is run through the R code, the associated R code, the input file with that R code is set up basically identically to the rest of what we're going to see here, starting with this purple block. The purple block, these are inputs that can be directly measured from fossils. So we have stomatal density on both sides of the leaf, and similarly for guard cell length and guard cell width and the carbon isotopic composition of the leaf. The one difference, and you're going to see this for the remainder of this little video, is with each variable, there's an N, a capital N column associated with it. And what we're looking for here is some sort of description of what, so if we're looking at this N column, what was abaxial stomatal density based on? So it could be the number of leaves, which is in fact what you see here. And or if you want to give a more general description, this will make a little more sense as we move a little farther to the right of how that parameter was estimated. You can type that in here. This little green block here is mostly associated with the delta C13 of the atmosphere. How was it estimated? So for example, if it's a Cenozoic estimate, you could use the model of Tipple et al. 2010. That's a popular choice. But whatever you used, you want to put the actual value and uncertainty, and then what it was based on. So you can see here, this was based on Tipple. And then the last Well, I guess second to last block here is in orange. This again continues to follow how the columns are set up in the input code for the Franks model with the addition of these n columns. These are variables that need to be estimated. They can't be directly measured, probably from a nearest living relative related to the assimilation rate, the different conductances, these so-called, well, these scalars 1 through 5, which allow you to convert or translate stomatal size and density to stomatal conductance. So you can see here these n columns now give a more general description of how, in this case, the CI to CA not input, how that was, what the value of 0.66 was based on. And lastly, these last 4, 5 columns, you're probably just going to drag down and use the defaults that is typically used with the Franks model. If you want to tweak with them, you can, but you should have strong reasons for doing so. You might want to reach out to me related to the discrimination of Rubisco, diffusion ratio, the CO2 compensation point, the leaf temperature. This fixed A column, this came up, this was introduced in the Kowalczyk 2018 paper, which recognized that when you're working with living plants where you might know, might be measured the assimilation rate, you don't want that assimilation rate to float, which is how the Franks model, the default is set to do. You want to fix it, you type in yes. But with fossils, I can't really imagine a scenario where you would be typing yes here. You probably are just going to drag down no. You want it to be able to float, and that's the default way that the Franks model runs. The last thing I'll say is if you think that there's a need for additional columns, you can do that. Just make sure you do it all the way to the right here. You don't want to be adding new columns in the middle, because then that's could potentially screw up how we automate the data scraping. So you can add new columns to the right. That there's no problem there. And kind of along that vein, let me just say one more thing. With the biostratigraphy, the stratigraphic level column here potentially could be quite complicated, that you can't really type in a single box. So there might be a whole stratigraphic section, for example, that's beautifully illustrated in the paper that you're working with. You can always add additional tabs down here. You can add additional tabs and put whatever you want in there. That's fine. There's no problem with doing that. And you could paste figures in. You know, just make a note of what you're doing in the appropriate cell to alert the readers who are looking at your template, you know, what exactly you've done. So hopefully that helps out. I'll say once again that, well, thank you. And if you have any follow-up questions or potentially some suggestions for improvements, definitely, I mean, we want to hear from you. So feel free to reach out to me or any of the other stomatal experts on the CO2 PIP team.